Hi, folks, welcome back. Today, I want to talk about a couple of contradictions in the studies related to the productivity gains from AI agents. And I was thinking about this as I was making my last video. In this last video, I looked at this very broad study of AI agent usage that found really large gains in terms of coding throughput without any decline in quality. And while I was making that video, I was thinking about this study from METR that came out earlier this year, and its headline finding was very different. In this study, they noticed that developers saw a 20% slowdown in their coding velocity while actually feeling that they were 20% faster. So it felt faster, but was actually slower. And on the face of it, these two studies really seem to be contradicting each other. So what gives? So in today's video, I want to take a deeper look at what each of these two studies are saying and why they might not be so contradictory after all. Now, I'll state my own personal bias right up front. I work in AI agents. I make my livelihood from it. I work for an AI startup that is building AI agents. So I obviously have a bias. I want these things to work. At the same time, I'd like to think I'm a rational person that, if presented with data, can change their mind. But anyway, that's my bias. Make of it what you will. All right, so I made this table to compare and contrast these two studies. The left one is the METR study, and the right one is uh, by Sarkar from the University of Chicago. All right, so the headline findings, like I said, very contradictory. METR found that devs felt they were 20% faster, but were actually 20% slower. Whereas in the Sarkar study, you found huge gains, no quality decline. Now let's dig into the details of how these two studies differed and what exactly they looked at. Now, the METR study had a very small population size. They found 16 open source developers. On the other hand, the Sarkar study was massive in comparison. The population was almost 87,000 people across 1,000 companies. So that's huge. That was actually one of the most striking things about that study. What was the experience level of these developers? For the METR study, they found people that were very experienced and had been contributing to an established large open source code repository for years, for more than 5 years. Whereas for Sarkar, it was a very varied population. It had a very broad distribution in terms of junior versus senior people, years of experience, and the code base itself also across such a large cross section of companies was highly varied. It was probably more enterprise kinds of code bases as opposed to a large old open source code base. The tool in both cases was the same or very similar. It was Cursor Agent, maybe at slightly different points of time. And so let's look at the tasks. By the way, both studies also looked at similar time periods, so early to mid 2025. So you can say that the capabilities of the models and agents that they were looking at were roughly similar, maybe not exactly the same, but roughly similar from the same time period. Now, what were these tasks? For the METR study, they came up with a bunch of tasks that the developers themselves chose. These were bug fixes or refactors that were on their to-do list. And then they broke up these tasks into two buckets, one which were implemented without AI help and the other with. In the Sarkar study, there were no cherry-picked tasks. They were just tasks that came up in the regular day-to-day enterprise work of this population. And then here's the big difference. What was the metric that each of these studies was measuring? The METR study was looking at time to create a commit or time to create a PR. So how long does it take me to write a piece of code that is more or less done? On the other hand, the Sarkar study was looking at output or throughput metrics, how many lines of code got merged into the code base. If you look at these two things in the software development lifecycle, time to PR is something that comes very early in the cycle, whereas merged code or lines of code in the repository is much, much later. It's almost close to the end of the development lifecycle. So if you break it down this way, you'll see that these are not altogether contradictory. In the METR study, they took very experienced senior developers who were working in a code repository that they had been working in for years. And what that means is that when faced with a bug fix or an implementation task, a senior developer like this already has a pretty good idea of how they're going to implement it. So it's not very surprising that AI and fixing whatever AI came up with was a net slowdown. The Sarkar study, on the other hand, looks at a much broader cross section of developers with varying levels of experience in their individual careers and also with the code bases that they're working on. In my opinion, the Sarkar study is much broader, and because of the breadth and variety of the population and the code bases and the companies that it looks at, comes up with a much more robust finding. One really illuminating article is this personal reflection by Dominic DeNicola, who was one of the participants, one of the 16 people in the METR study, and he has written this long blog post about his experience participating in this study, what the task was, how he did it, and what he thinks about the results. So I'll link to this down in the description, but I want to highlight a couple of things. One of the important things is that this METR study isn't exactly an A-B comparison in that you didn't have someone working on the same tasks with and without AI. You just broke up all the tasks into two buckets. Author says he didn't have a lot of experience coding with agents, particularly Cursor. And this is interesting. A large part of this is due to my position on the Chrome team at Google. This is interesting because, yes, if you're in a big tech company like Google, you will actually be prohibited from using external LLMs and you will be required to only use internal tools and LLMs like Gemini. He calls out how bad the Cursor agent was fitting into the existing code bases style. And this is one of the things that comes with an open source repo that's years old. It probably has its own very specific style. Eventually, he refined his prompt to get into a good flow. And he speaks to his kind of personal thoughts on why it felt faster. And I think what's happening is that because there's more activity, you're going back and forth in a multi-turn conversation. It feels like there's a lot of activity, there's a lot of forward movement, but the total end-to-end time might be longer, which is why it feels faster but is actually slower. One interesting thing he calls out is that if you were using an agent like this as part of your regular day-to-day work, you would actually spend a fair amount of time setting up your prompts and scaffolding and cursor rules and all that stuff properly to get more productivity out of it, which was not the case for this study. They went in cold. But this is where I think he's really looking to the future, and I agree with him, which is that to really get the most juice out of these agents, you need a different mode of working, which is instead of pair programming with one agent in a one-to-one mode, you've just got to set off a bunch of parallel agents in the background. So thanks, Dominic, for writing this more inside look at the METR study. All right, I hope you found that helpful. If you like content like this, consider subscribing, like the video, and I will see you next time.